Okay. Now, how did everyone did pretty good on part 1 of the preparation assignment?
Yeah.
Yes.
Yeah.
Okay, so then we'll move on to part 2. So, did you guys all do part 2 ahead of time?
Yes.
Yeah.
Okay. So do you want to walk through it, or do you just want to see if anybody had any questions?
I didn't really have any questions once I figured out where to put what.
What was that, Natalie?
I was fine. Sorry.
You're fine? And Giselle, how about you?
I was fine too.
Oh, okay. I had to watch the video on how to make the plots because I was getting a little confused. I don't know why, but I figured it out this morning, so I'm good. I wish they would put the SPS ones, the plots on there so I could see. I mean, they look like the Excel ones, but they, you know, I want to make sure mine are exactly right.
If you go to the tutoring videos, he shows you the SPSS ones. That's what I had to do to make sure I was getting mine right, because I couldn't remember how to do a QQ plot.
Yeah.
So I just went into the tutoring ones.
That's what I did this morning. I just watched those this morning. So, okay. So then, do you guys just want to jump into the test?
Sure.
Is everyone comfortable with that?
Yeah.
Yeah.
Okay. So group meeting, lesson 23. Oh, what are you doing? You're so silly. Okay. All right, everybody ready?
Yes.
Yeah.
Yeah.
Okay, so number 3, the true linear regression equation is where beta 0 and beta 1 are unknown. What are the null and alternative hypotheses for beta 1? So it's
The third one?
B1 is equal
Yeah.
and then not equal to, right? Yeah, the third one.
Yeah. Mm-hmm.
Okay, a residual is what is left over after doing simple linear regression is the difference between the observed value y and the value predicted by the regression line. Is the difference between beta 0 and beta 1.
I think it's the second one.
Yeah, that's what I was going to say. Is the difference between the observed value y and the value predicted in the regression line.
Yeah.
Okay.
I don't think I had known that one if I hadn't watched that video this morning. But everyone agrees, right?
Yes.
Yeah.
Okay. 5. A plot of residuals supports using linear regression when there is no pattern, right?
Yeah.
Where is that? You see
That's not on there.
you see a pattern. Wait, a plot of a residual. The residuals are all positive. You see a megaphone shape. The residuals look normally distributed with a 0 mean. Wait. Oops. I thought it was when it was like crazy and they were all over the place, right?
Yeah,
That's
it.
what I thought so too.
But there's also when you make the QQ plot of the residuals, you see the pattern that goes up.
Oh, the positive. The residuals are all positive.
Does that?
Points are close to the line for the QQ plot is what you want to see. The residual plot, you want to see no megaphone shape.
Yeah.
Yeah, so it's definitely not A or C.
Yeah.
The residuals are all positive. Let me go.
This,
I don't remember
So
reading
there's-
about that, about a 0 mean.
I don't remember
so
reading
which one is the one where we have to see them close to the line?
That's the QQ
The
plot.
QQ plot.
Okay.
Okay.
So would it be the residuals look normally distributed with 0? With 0 mean? I don't know. Because I don't think they would have to be all positive.
Okay, as a skip where the x-axis shows the independent variable on the x-axis order. If a linear regression is appropriate, then the residuals plot will show no patterns and will consist of a random scatter.
That's all it says, right?
Yeah. If there's a pattern in the residuals, it suggests that linear regression is not appropriate. Patterns that could arise in a residual plot: curvature, megaphone. Yeah, none of those options make any sense.
I know.
Not in my notes. And
Yeah.
I swear I wrote down everything like word for word from the book.
I did that too.
You want some snacks? I will. Okay. Here. Want some too? If I want them to leave me alone, I just throw fruit snacks at them. Leave me alone. Have some fruit snacks. Is anybody else seeing?
Oh no.
You see a pattern. A plot of reports using linear regression. No, you
I'm
don't.
going to the reading, but it doesn't
Don't.
talk about anything.
I do remember something about 0, but I thought it said something about the sum of the residuals are always 0.
I would say maybe the most plausible one is the last one, right? Like
Yeah.
maybe they're referring to the QQ plot, and so if they're referring to the QQ plot, then we want to know if it's normally distributed, and that would
And that's what I was thinking.
our most logical answer, right? The error term E is normally distributed. Is what we want to know, and that's when we make the QQ plot of the residuals. I don't know. I would go with the last one. What do you guys think?
I think the last one as well.
Yeah, okay.
Yeah,
All right, let's do it.
I think that's the best educated guess.
Right? All right, 6. Compute the residuals for the math self-efficiency. Okay, so I guess we're going to pull that out. Use the confidence data as the explanatory variable and the score data as the response variable. All right, let's pull this up.
Okay, my VMware is not coming up. I started it when we started the meeting, but it hasn't come up still connecting. No. So if you want to go ahead and do it, and I'll just follow your lead, that's fine.
Yeah, that's fine.
I'm having the same problem.
It always takes forever to come up.
Bring me a comb so I can do your hair. You need to be taking your toys upstairs. Okay.
That's what you want to use the computer for? Then yes, you can use it.
Okay, here we go. Woohoo! That worked. All right. Okay, so what does it say? Use the confidence channel as the explanatory variable. Regression. Like here. Okay. Explanatory.
You want me to code it?
Okay, anybody remember which variable is the explanatory variable? Is it the x or the y? That's
The X is your independent.
But the explanatory, is that the
Yeah,
x?
it's X.
Okay, good. Okay, so explanatory is our independent variable, right? Confidence rating as the... No, I didn't want to do that. No, go smaller. There we go. Oh, where did it go? Okay. Sometimes I don't know what I'm doing. Analyze. Come on. Linear. Okay. So confidence rating is our independent variable, right?
Yeah.
And then our dependent variable is the score?
I put the score as X and the confidence as Y.
Oh.
Oh, you mean a confidence rating is our dependent variable?
That's what I put.
All right, let me go back and look. Okay, so the response variable is the independent variable. So response variable is our score. Oh, okay, you're right, Natalie. There's you flip them around. So this goes here. Okay, fine. It goes there. Okay. The plots. No. Cancel. Statistic.
This thing's still saying connecting.
Yeah, so is mine.
Like, maybe tomorrow it will load.
Maybe tomorrow. No. Cancel. Save. Unstandardized. And then we want the unstandardized residuals, right? Okay.
Yeah.
Continue. Okay. There we go. Okay. So now we want to go. What statement best describes the residuals? Okay, so we just got to look at our residual. Data, right? Natalie, is that what you're doing? You're just looking at your residual
Yeah.
column?
Yeah.
Between -40 and 25, the residuals are all negative. No, they are not all negative. The residuals form a linear pattern. Well, let's just check that out and see if they do. Analyze, let's see, graphs. Scatter
Patterns.
Fine. Okay, so I forget.
Sorry, my computer's going crazy, but I'm on the making a scatter plot.
The residuals are gonna go in. I forget. Do you guys remember? You're making a residual scatter plot. Do they go? The residuals go on the x or the y-axis?
Why?
The y. Okay, that's what I thought. So y, and then what is our x? So our x is
The score.
4. Okay. I don't know, Natalie. What's yours look like? Mine looks like a big blob that goes horizontally.
You could share it.
Let me check. I have it right here. Mine looks funny. It doesn't look like the other one where it's scattered everywhere.
Yeah, mine looks like a big blob in the middle. You want to see? Let me share mine. I'll show you mine. Screen share.
Why don't you go potty and go get dressed?
Yeah.
Okay.
Okay, you see that?
Yeah, that's how mine looks like.
Okay, so that's definitely not. Would you say that was linear?
No.
Okay.
I don't know.
Well, linear straight across the screen, right? Like in a horizontal line,
Yeah.
right?
But
All right.
remember that this one is a residual, so it doesn't have to be linear. It has to be crazy.
Oh yeah, that's right. So then they do follow a linear pattern.
Yeah.
Okay.
It says, yeah, because we just talked about it. It says the linear, whatever.
Yeah, so you want to see a crazy pattern on that one, and that tells you that it forms a linear
Okay.
pattern. Everybody else agree?
Yeah.
So we would do the residuals form a linear pattern?
Yeah, so on the box on part 1 it says that there is a linear relationship between x and y when there is no pattern in the residuals.
Yeah, which there's no pattern. It's just a big blob of dots. Okay, cool. So we're going to do C for 6?
Yes.
All right, I'm going to stop sharing. Okay, cool. All right, based on the QQ plot for the residuals, what? Okay, so let's run a QQ plot for the residuals here. Analyze.
I'm sorry, ladies. I feel so
Still
useless.
connecting.
Sorry, Sadie, what was that?
And I'm still connecting.
Yeah, I know. I feel so useless too. Like, just come up.
Okay, I just did all this, and now I'm forgetting how to do it.
Okay, I'm gonna try to get it done.
Let me just look at my notes. Estimate regression coefficient.
Oh my goodness, my stomach hurts. Oh my God. Third.
Don't you want?
Residual plot. Oh, I just need to look at that. No, I should have just brought up the.
Yeah.
The green watermelon.
Hmm.
That's my.
Isn't this one you just put in? Just put in the residuals, right?
Yeah.
Plots. Normality plots of tests. Okay. Okay, so hopefully I did that right. We'll find out here. Okay, so have you put yours together, Natalie? What's yours look like?
I'm doing it through Excel, so give me 1 second. It takes a little
Okay.
bit.
All right, well, I'll screen share mine so you can see it, and then we'll see if it looks the same. Yes, Miriam? Calm down. Okay, that's what mine looks like now. Why do you have no pants on?
Okay.
My children that like to take their clothing off. Is that what yours looks like, Natalie?
I'm still trying to do this.
What?
Hey, are you moving close to your body?
Okay, can you clean it up with this? And then just step on it or push on it so that it absorbs the milk. There you go, good girl.
Heavy.
What? Just take it easy, one fruit snack at a time, okay? Take it easy.
Okay, yeah, mine looks like yours.
Okay, perfect. So then we can say, hey. Calm down. So then we can say the residuals are normal, right?
Yes.
Oh, I'm done.
I'm still not sure about number 6, though. Sorry.
So 70 say the residuals are clearly normal.
Yeah. For 7, yes.
Oh, wait, shoot.
I
Oh,
use software to create a scatter plot of the math. Data. Give me a scatter plot of residuals.
You say you're still not sure about number 6, Natalie?
Yeah, but that's it. I don't know why. I don't know. It just bugs me.
Okay.
But that's fine though, because the other 2 don't make any sense. So it makes sense that it's the
We'll
3rd
be
one.
here in a couple minutes.
Okay, so should we move on to 8?
Yeah, 8.
wait, hold on. Just making sure 70 C?
Yeah.
Yes.
Okay. Let's
All
move on
right.
to 8. Sorry.
Use software to create a scatter plot of the math self-efficiency data. Given the scatter plot, residual plot, which has 5 assumptions about linear regression are satisfied by the data. Check all that apply. All right, so let's create a scatter plot. Oh, stop. Like, scatter dot. Yes. So in that, it's going to be our Wait, I forget. Hair, yes, that's my hair. Confidence, data, and score. Okay, now.
I think it's the first three, and I did not check the last two.
Okay, so my scatter plot looks like a big hot dog going
That's
linear, right?
yeah.
Is that what
Yeah.
you're looking at?
It's still linear. It just looks like a.
No, not all done. Okay, so there is a linear. Ow! Stop, Olivia Maria Tempa. Let go. There's a linear relationship between x and y. The residuals are normally distributed. The variance of the error term is constant for all values of x. I would say the opposite. I would say all 5 of them, right? I mean, because we can't independently measure those last 2, but
Well, I was
know,
looking at, yeah.
but we know that x and y aren't related, right? That y doesn't tell us anything about x, right?
Yes.
Oh, Arya, no.
X values are measured without error. I would say all 5. I don't know. What do you two think?
I put all 5.
Yeah.
Yeah, I put all 5 too.
Okay.
All right, 9. Shh. What is B1? The estimate for the slope. Okay. Let's look at our data here. Shh, stop. Okay. So, Natalie, did you get 0.042 for your slope?
Yes. Yeah.
Okay. So,
Zero
we
four.
want so it's 0.0 for that one.
Okay, thank you, ladies. I'm sorry that I'm still connecting.
You are
I
okay.
can't.
For the confidence interval, did you get 0.035 and 0.048?
0.035 and 0.048, yes.
Okay, perfect. Thank you, ladies.
Wait,
So-
that's not an option here.
No, but the last one, 0.023, huh? That's weird.
Not you.
That's really.
Well, I guess we just go with the last one. I mean, it's closest. We both ran it the same. We both got the same answer.
I know. I wonder what.
What answer did you guys get for the confidence interval?
0.035 and 0.048.
I think it's a typo.
Yeah, we can just go with the last one.
I hope so, because the other the top one doesn't match anything.
Yeah, the other ones are too big for what
Yeah.
we got.
How, Olivia? No. Woman. All right. So 11. Based on the evidence and using a level of significance of 0.05, what decision would you make? So hypothesis for P1. Okay. My level of significance is 0.000.
Level of significance. Sorry.
Yours
So
is,
we reject and null.
yeah. Yours is
Yeah.
going to be a little more specific than mine, right?
Yeah.
What's yours?
Hold on. I'm trying to see on my.
I can double click it.
I got
33127 like 0.000 point.
I don't know where to find it on Excel. What am I finding? T score?
No, you're looking for the level of significance. which in SPSS is under SIG. But I'm not sure about Excel.
No, I'm using Excel and it doesn't give
No, I'm almost done. 3 more questions.
it. Yeah, I'm looking at Excel and it doesn't give it to you in Excel.
Are you going to go play?
No.
Okay, I'm going to keep him until you decide to go play.
It should give it to you in Excel.
What's it?
You want milk? You want milk? No or yes? Milk? Alright, hold on, let me get your milk. Hold on. Oh, that's wrong.
I can't find it on Excel.
Did you look in the instructions?
I'm trying to find it here.
Look in the book and see what it says in the book where you're supposed where you can find it in the book. I just hate to move forward with only one. You know what I mean? I don't want to be wrong, and then everyone else gets it wrong because I'm wrong.
I'm sorry, JC, that mine is just not loading.
Mine neither. I don't know why.
It's fine. Let's see. Let me look it up in the book.
Alright. Let me watch your number again and see if I can find it on that. On the numbers they give me.
I got 000, but then when I click on it, it's it's hold on. It's 0.3127 negative 24. So move the decimal point 24 times. All right, individual prep. All right, data.
I have one where the number moves 24 times, but it's 2.4345.
Okay, Excel instructions. Residual. Making a residual plot. Here we go. Okay. Note that in the output for Excel, the p-value is given in scientific notation. Also note that there are 2 values under p-value. So in Excel, it should say p-value. One is for the slope, and the other is for the y-intercept. In this class, we will always be looking at the slope, which is the bottom or the predictors. So our p-value, is written as. So you should be seeing something that looks like.
With the notation, I have it here, but it's not the same number as yours. It's a bunch of zeros, 24 zeros before.
Yes, mine's 24 zeros. So basically, it's going to be 0. I mean, basically, it's smaller than our level of significance. Okay.
Yeah.
All right. So,
And it doesn't actually ask for the number.
Yeah. All right, so we are going to reject the null, right? Because our p-value is less than 8.
Yes.
Okay. Or the hypothesis test for B1 slope. If you reject null, what does this mean? There is sufficient evidence to conclude that the slope of the regression line is 0. There's sufficient evidence to conclude the slope of the regression line is not 0.
The third one.
Yeah.
The third one?
Yeah.
Yeah. Our null hypothesis is it equals 0. If
Yeah.
we fail to make that, then it means it is
It's
not
not
0.
0. Okay, cool.
Okay, so 11 was B, right?
Yeah.
Oh, C.
For the
Okay.
crocodile data, which variable is the dependent variable? So it's the body.
Body.
So that's what we decided for the crocodile data that we used last night, but this looks like a different one.
Yeah, but they're all the same, basically.
Yeah, they're all the same.
They're all the same. We all know the head length, and we want to predict the body length based on the head length.
Okay.
Since the 99% confidence interval for this data is 7 point, oh, I guess they're talking about the crocodile.
Yeah.
What can you say about B1? Confidence interval does not contain 0. Let's conclude that is not equal. So there's a 99% chance that the confidence interval contain no. There is insufficient evidence to address the null.
I am so lost. I don't see what the confidence interval has to do with us being able to tell any of those things.
What can you say about the slope? So what can we say about the slope?
Okay, that's the
slope. Since the confidence interval does not contain 0, there is sufficient evidence to conclude that B1 is not equal to 0. I would say that, right?
Okay.
If you're talking about the slope. There's a 99%. That statement is never true for any confidence.
Yeah.
There is insufficient evidence to reject the null hypothesis.
Yeah. So the last two, the A does not make sense because I don't know what it's saying, but B and C don't make any sense. They're wrong. So I'm assuming A.
Yeah, I would say A.
Okay.
Are we ready?
I mean, we could just run it. We could run the test and see. You know?
I don't really know. Well, let's go. Let's go ahead and submit. I think it's A.
That is the which crocodile data? The okay. Stupid.
Are we running it or submitting it?
I was gonna run. Were you gonna run it, Natalie?
I was gonna submit it because the
Oh,
last two don't make any sense.
Okay. Okay. You want to submit, or do you want me to run it? Anybody want me to run it?
You can run it if you want. Just make sure. Yeah, just run it to make sure.
It's gonna take a minute.
That's okay.
Crocodile. Man, I just trimmed that kid's nails because she got me good.
I hate it when that happens. I am laughing because I live it every day.
No, I know, right? She's so aggressive.
I got it to Daddy.
Alright.
Oh, yeah?
Yeah. It's when you
So I'm gonna go.
Hey, I'm finally in now that we are finishing up.
Yeah, I gave up.
It's taking a long time to load my desktop, but it finally made it in.
Hey, you do this at the corners?
I want you to do it on the corners.
No.
Alright.
You like the puppy?
Yes.
Oh, come on. Oh, okay. I did that. I forgot to mark the box. I'm like, what did I do wrong? There we go. Okay, so 7.1 and 8.1. Okay. There is an end. Okay. So our little significance is 0.000, so we would reject the null. So the last one definitely is not true.
Yeah. Well, the second one is not true, so it has to be A.
Okay. All right. We got
So let's go ahead and submit.
All right.
Oh, no.
Ah! Oh,
What happened? Oh,
we messed up.
it's okay.
So it was just the first three. Natalie, you were right on that one.
That's okay. What happened to it? I don't understand how the confidence level for V1 is 10.708.
Right?
I don't understand.
Yeah, because that's not
what
right.
Those are not the numbers I have here. It makes no sense.
Graph. Let's see. Analyze. No.
And on 6, why would it be that the residuals are between about 1 minus 40 and 25? I don't.
Well, let me look at their residuals, but it makes no sense. It really doesn't make any sense.
Well, you must have done something wrong when we ran our test. Right? I mean, that's the only...
It doesn't make any sense.
Right? I mean, for both of us to get the same answers, and then... Analyze. Regression. Linear. Unless... And the explanatory... I'm like, unless we put the variables in the wrong places.
So did you guys, for that one, did you guys have the confidence data as X and the score as Y?
No, I had it flipped around. The score is X. And you know what? I just submitted the data flipped around, and it gives us that data, the 10.708 and 14.742.
Okay, so then we just had our variables in the wrong place.
Yeah.
Place it near this. Right click.
It's okay, ladies. It happens. At least we know it won't happen on the test.
Oh, you're so
Because we
sweet.
already did it.
You are so sweet. Oh my gosh, I can't believe it.
Oh, it's fine. It's.
Amy just wants to run the test again. So are the scatter plots different?
No, they're about let me check. Sorry,
Somebody poop.
Analyze.
they're about the same.
Here. Okay, so we want to flip this. So then
Dog?
4 wants
If
to
you
be
flip
independent.
If
And
you flip,
confidence.
you get a slope of 12.725.
I'm not gonna help you anymore, okay?
Save. And then continue. Okay. Yes, That's what, okay. So everything's flopped around. Just kind of flippity flippity.
It's okay. That's what happens with math. You know, you just do one small little thing wrong and everything just gets off balance.
The explanatory variable. When I looked at that in my notes too. Okay, the explanatory variable is the x variable. So the x variable would be the confidence data.
Well, it would make sense though, because the confidence level, because you know, in this test, it depended on the confidence level, and they would check their score, see how they did.
Right.
And so confidence would be, yeah. The more confidence they had, the higher the score. The less confidence, the less score, or something like that.
Maya, I heard you.
This bugs me. I'm sorry.
No,
It's okay.
Yeah, because
R-O-O-J-O.
no. So then for the residuals being between those two, we just look at the line of residuals and see what our lowest and highest is, or is there something on the regression
When
test
I have to
tells us
when I
that?
have to make the QQ plot, I put the residuals. Yeah. Well, when I have to do the QQ plot test, I have to put the residuals in chronological order. And from there, I notice. Well, Excel does it for me anyway.
Oh, okay. Yeah, I guess that should have flagged the confidence interval when our confidence interval was off.
It just bugs me. I'm sorry.
No.
It's fine. Don't. Yeah.
Sorry, ladies. Well,
No,
maybe
it's
we
okay.
can tell him.
That's all right.
Maybe he can let us do it again. Somebody
So,
email.
you know, it's not like we could do it alongside with you. So, I mean.
Yeah. Okay, so then I guess do we want to discuss the remainder of our project?
Yeah.
Sure. Yeah.
Okay, so we have make inferences and take action, which is due. And Natalie, you're doing make inferences, right?
Yes. Sadie talked about that. I think it's just a one-person job. I did the other one. I don't know if you wanted to take that one.
Oh, say that again?
It's a one-person job. That one, the group project.
Yeah, they have kind of combined make inferences and take action, and it's just one document.
Okay.
Oh, okay.
Test your hypothesis in no more than 2 pages. Write up the results of your hypothesis. Use the guidelines below to write it up. Title of this assignment, names, research question, hypothesis.
I don't know if you wanted to take that one since Sadie submitted design the study. I did the second one, and Giselle did the describe the data.
Oh, okay, yeah, I'll do this one. Sure.
Okay.
And that document is still available in Google, the one that Giselle created, right?
Yeah. So you can go from there.
And I can just look at that one and then go from there. Okay. Okay, so then I'll do this.
If not, you can always download it from your iLearn graded one.
Yeah.
Oh, that's right. Good point. And then I'll do this, and then I'll put it in Google Docs so that you guys can take a look at it.
Okay.
Yeah.
Sound good? And then if you want, you can make any changes or any corrections and let me know what you think.
And let us
Okay.
know how we can help you if it's it ends up being too much work, because it was a big help when you girls helped me do the
Yeah, sounds good. No, I
the
think
rest
this
of
will
the
be pretty
data. So
simple because I ran the hypothesis test when we were doing it
yeah,
and looked at
yeah.
it.
I mean, most of the hardest work is already been done. So
Right. Yeah, exactly.
so
Okay.
if anything comes up, let us know. We'll be
Okay.
there and help you.
Sounds
Yes.
good. We'll do. And then what about our PowerPoint?
Point.
Yeah.
Is he giving us any kind of an example to go by, or
I don't think so.
'Cause, I mean, how do you create a PowerPoint out of our information?
I guess we just lay it out?
Well, I think the PowerPoint presentation says your PowerPoint should include the following: design the study, background information, data collection, describe the data, make inferences, take action.
So then I guess we just have a slide for each, right?
Yeah.
For each section
Yeah.
of our project, right? So like the first one would be
Yeah.
our research question or whatever, and then, go from there, right?
Yes.
Okay. It should be fairly simple.
In the kitchen.
Yeah, it should be about 1, 2, 3, 4, 5 slides long. It should be really
Right.
simple.
Yeah.
Okay, and then how do we want to start on that? Do
We just, create it in Google Docs so everyone can edit and put in their sections.
Yeah, I think
Yeah.
that's a good idea.
Oh yeah, because Google Docs does have the presentation one. It doesn't. I'm not sure if it translates very well into PowerPoint for Word, but we can.
It should. With Google Docs, you can.
Okay. Okay, then who wants to just create the initial PowerPoint for us to plug everything in?
I can do that.
You want to do that? Okay, cool. All right, and then I'll get the ball rolling on this guy.
And should we all plug in whatever we're in charge of originally, or?
Yeah. I think we can help Jackie do the take action one because everyone's going to have an opinion about what we should do or whatever.
Well, I have no idea about what we should do, honestly. I mean,
if you want
I don't know.
to, because on the PowerPoint presentation, it's 2 slides depending on make inferences and then another slide about take action.
Yeah, that's fine. I think then just after we look at this last document that I'll submit, then we can figure out what's going to be on there.
Okay, so we can take a slide each, and then the take action one we'll all put in our thoughts or whatever.
Okay, sounds good. Well, I'll post this up when I'm done with it.
All right.
Okay, and then we'll meet again on Thursday at 9, right?
Okay.
Yeah,
Are we
just
meeting again? Do we have a group meeting?
Yeah, because we have to do the pre-test for the final.
yeah.
Oh, you're right. Yes, okay.
Okay. So then we'll meet Thursday at 9, and we can probably discuss any other details about the project then.
Okay, sounds good.
When is the project due?
It is due. It is due. Saturday of week 12. The inferences take action is due Saturday of week 12. So this Saturday, right?
Yeah,
Oh,
and
wow.
the PowerPoint isn't due till July 23rd, which is next Thursday.
Okay. So we still have a while to do the
Yeah.
PowerPoint, but the inference stuff
But
is
we
to
can
decide
probably
on.
we can probably get the PowerPoint out of the way this week.
Yeah, because all we need is, I mean, all the information is there. We just need to make it pretty.
Yeah.
Yeah. Basically.
All right. Sounds good
Okay.
then. And I'll post that. I'll put that on Google Docs as soon as I'm done with it. You guys can
Okay.
look it over.
Okay.
Okay.
All right. Otherwise, I'll see you on Thursday.
All right,
right.
then.
Bye.
See you ladies. Bye.